Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem ZigZag tree traversal. Previously, this problem has been asked in companies like Flipkart, Amazon and Microsoft. So let us first read the problem statement and then we'll see what we have to do in this particular problem. So the problem says that we will be given a binary tree which will have n nodes inside it, and we have to find the zigzag level order traversal of that particular given binary tree. So suppose that we have been given a binary tree which is like 1, then we have 2, then after that we have 3, then for 2 we have the left child as 4, then we have 5 as the right child, then we have 6 as the left child of 3, and then we have 7 as the right child of 3. So if this particular tree has been given, so in the zigzag order traversal, what we have to do is, we have to do level order traversal only, but in zigzag pattern. Now what is zigzag pattern? So zigzag pattern is like this. First of all, let's say you will go from left to right, and then in the next time you will go from right to left. Then again you will go from left to right, then you will go from right to left. So basically what will happen is you will go from left to right. So firstly you will write 1 here, okay. Then after that you will go from right to left. So what will happen is, first of all you will write 3 and then you will write 2. Then after this what will happen is you will go from left to right again in the next level. So what will happen is you will now write 4, then 5 and then 6 and then 7. So that is what zigzag level order traversal is about, and you can see in this answer we have 1, then we have 3, 2 and then we have 4, 5, 6, 7. So basically if we assume and give level some numbering, so let's say we have level 1, then we have got level 2 and then we have got level 3. So let me number these levels. So let's say we have got level 1, then we have got level 2 and level 3. If we number the levels like this, then you can observe that whenever the levels are even, then we have to do what? We have to reverse the level order traversal for that particular level. Now how can we solve this particular problem in a simple fashion? So what we need to do is we need to use one more concept, that is the concept of number of nodes at a particular level. So what we can do is we can store inside a list, we can store the number of nodes at that particular level, and then after that, once we have stored all the nodes of that particular level, then if the level is even, then we can reverse that particular list and then we can insert that list in our final answer. This is how the approach is going to be. So let's try and see what we have to do here. So suppose that we have been given 1. So let's write this again. Suppose that we have been given 1, then we have been given 2, then we have been given 3 here, then we have been given 4, then we have been given 5 here, then we have been given 6, and then we have been given 7. So suppose this has been given to us. Now what we need to understand is that firstly when we are starting off, so every time when we are starting off, so we need to take a queue. That is one thing that is very clear from the very starting. So what you need to do is when we start, so initially we have got 1, so we'll insert the root node inside the queue. Once we have done that, so now I will take the size of the queue. So right now the size of the queue comes out to 1. This indicates that in the current level there is 1 node. Okay, and we will take the size only when the size variable becomes equal to 0. After taking out every node from the front, we will keep on decreasing the size. The moment the size of the queue becomes 0, then we'll update the size of the queue with whatever is the current size of the queue. Okay, so if you will see, firstly we have got the size as 1. Okay, so we'll have 1 and then I will store it in a list, and right now the level variable will also be 1. Okay, now what happens is like we have stored 1 and then we pop it out. Since we have used 1 node, so we will mark the size as 0, and obviously because of 1 the left child existed, so it has been inserted, and the right child also existed, so the right node 3 also existed, so we'll insert it. Then after this, the moment we see that the size has become 0, so what we will do is, like when the size variable becomes 0, then whatever is the size of the queue, whatever is the number of nodes inside the queue, we will update the size to that. So now the size will get updated to 2. Why the size gets updated to 2? Basically because there are 2 nodes currently inside the queue. Okay, so inside the queue currently we have 2 nodes. This indicates that in the current level we'll be having 2 nodes. Now again we declare a new list, and what we will do is we'll store all the nodes of this particular level. So what we will do is, firstly we are at the front, that is 2, so we'll take out the node 2. So the current node will be what? Current node will be 2, and since you have taken this node 2, so you will insert this in your temporary list, and then after that you will insert the left and the right child of it. So left child is 4, it exists, and the right child is 5, so it exists, so you'll push it. Then after that, since we have used this node, so we'll mark the size as 1, so we'll decrease the size variable and it will become 1. Then after that, the next front node is what? It is nothing but 3. So we'll take out 3, and now the current node will be 3. So since the current node is 3, so we'll do what? We'll first of all push it inside our temporary list, and then after this what we will do is we'll decrease the size as well. Now the moment the size becomes 0, this means that for the current level the list has been stored, and now we need to decide whether we have to store the temporary list directly or we have to reverse it and then we have to store in our answer. So since the level is 2, so since the level is even, so what I can say is if the level is even, then we have to reverse our temporary list and then store it. So inside our answer first we had 1, then what we will do is we'll reverse this list. So because the level is even, so we can mark like the current nodes of the current level will now be 3 and 2. So we'll store 3 and 2. I will insert it inside our answer, and then after that we'll proceed further. So now once the size becomes 0, so because of 3, 6 and 7 have also been inserted. Now when the size has become 0, so again I will take out the size. Now what is the size? The size is nothing but 4. So this indicates that in the current level, that is the new level that I'm starting for, now the number of nodes are 4. Now what happens is we get the front node, so the front node will be 4. So we take it out. So currently 4 is stored, and so what we do is inside our temporary list we store 4. Then after that the front node is what? The front node is 5. So we take out 5 and we store 5 as well. Okay, because 5 does not have any left or right child, so we'll directly store it. Then what happens? The next node is basically 6, so we take it out of the queue and then we store it. As we keep on storing, so the size became 3, then became 2, and since I have used the node 6 also, so size became 1. Okay, because the moment I took 4, so the size decreased by 1. Then the moment I took out 5, so size came 2. Then the moment I took out 6, then the size became 1. So after this what happens? Now I take out 7 from the queue as well, and then what happens is the size becomes equal to 0, and then I store 7 in my list. Now temporary list. Now what happens is the level is 3. So since the level is odd, so this indicates that I don't have to reverse the current list. I will store it as it is from left to right. So what we will do is we'll insert this updated list, that is 4, 5, 6, 7. And you can see this is how we are getting the zigzag order traversal. Okay, so basically whenever the size variables becomes equal to 0, then the current level has been stored, then that particular level has been stored, and depending on whether the level is even or odd, you will decide to reverse the list or not. If the level, suppose you are starting the level from 1, so if the level is odd, then every time you will reverse the list and then insert it inside your final answer. So if you will see the time complexity for this approach, so obviously we are iterating through all the n nodes. So that would take order of n time, and the space complexity will also be order of n. Why? Because in the worst case, the number of nodes in the tree will be n. So let's try and quickly code this problem up and see how we can implement it further. So what we will do here is basically we will first of all declare a vector int answer, which will be giving us the zigzag level order traversal of the tree. Now what we need to check is that suppose if the root of the tree itself is null, so if there is nothing inside this particular tree, so if there is nothing, then we can directly say that we will return the empty answer. Otherwise, what we will do is we will declare a queue first of all, and we will do what? We will store the root node of the tree inside the queue. Now, once we have done this, then what we will do here is we will say that while the queue size is greater than 0, till that point of time we need to iterate, and also what we will do is we will take the size of the queue. So size of the queue will be nothing but queue dot size. So we can take the size of the queue. This will help us to understand how many nodes are there in the starting of the traversal. So it helps us to know that in the next level that we are going to iterate for, what are the number of nodes. Okay, and as we keep on taking out those nodes, so we keep on decreasing our size as well. So what we need to do is we need to also declare a temporary list, let's say as temp. Okay, and then after this we will iterate while the size is greater than 0. Till that point of time we will keep on iterating. Now this loop will not add any extra complexity because it is just a wrapper which is isolating the nodes of the current level from the next level. Okay, so what we will do is we will first of all take out the current node. So let's say node star current node will be nothing but queue dot front. So we'll take out from the front of the queue. Then we are going to pop this out. So we'll pop this node out, and then after this what we can do here is we can simply say that we will push it inside our temporary list. So we will say that temp dot push back the current node's data, because we only are concerned about the data. Once we have done this, so we will check that if the current node that we are at, if its left child is not equal to null, then what we will do is we'll insert the left child. So inside the queue we will push the currents left, and similarly we'll check that if the current node that we are at, if its right child is not null, so we'll push the right. So we'll say that if the current's right is not equal to null, then what we will do is inside the queue we will push the current's right child. Now one more thing that we need to notice is that we have not taken the level variable. So what I will do is initially I'll mark the level as 1. Okay, because I started the level from 1, and then after this what we will do is after this while loop traversal is over, then we will check that if the level mod 2 is equal to 0. So this means that if the level is even, then we need to do what? We need to store the list from right to left order. So that is why we need to reverse this particular list. So we can write what? We can write the reverse function where we need to reverse this temporary list, as we have discussed in the dry run also. So what we will do is we'll reverse it from the beginning till the end. Okay, otherwise if it is odd, if the level is odd, this means that we need to iterate it in the left to right order only. Okay, now after this is done, so inside our answer we'll push back the temporary list so that all the elements in this temporary list can be inserted inside our answer, and then we'll increase our level also, because after this particular level has been processed, then we need to process for the next level. Okay, so this is how we need to code this. What we have done is if the root is null, then we return the empty answer. Otherwise we have inserted the root node and then we iterate till the queue is greater than 0, till the queue size is greater than 0. We take out the size of the current node, and then what we do is we declare a temporary node, and we are doing what? We are iterating until the size is greater than 0. For that means for this particular level we are iterating for all the nodes. And also one more thing is that after I pop out the node from the queue, I need to decrease my size. So now let's try and code this to check if it is working fine or not. So there is some kind of error here. Let's quickly check. No matching for push. Okay. Okay, so what I've done is I've declared the queue of integer, whereas I should have declared the queue for the node data type, because queue will be storing node and not the integers. Okay. Now let's try and run it. It should work fine. Okay, there is another error. So answer.push, I should have written answer.pushback in C++ and answer.pushback this particular temp. Let's try and compile it again to check if it is working or not. Okay, so again it says that there is some issue, so I guess it cannot directly store this thing. So what we have done is inside the temp we have pushed the current data, and then after this whatever is the reverse temp we are pushing it, but it does not allow us this option. So what we can do here is we can simply iterate, and we can do what? I starts from 0, I is less than temp dot size, and then we can do I++, because the answer is not a list of list, so we need to insert it specifically. So what we will do here is we'll say that inside our answer we can simply push back the temp of I. So we can push all the values one by one. Now let's try and run it. It should work fine now. So you can see it is working fine on the sample test case. Let's try and submit this code to check if it is getting accepted or not. So you can clearly see that our code was able to pass all the test cases that are there. I hope that you have understood this problem and the approach clearly. Basically, we created a wrapper for every level, because if you are in the start, like if you are currently starting, so you take the size of the queue. The reason for that being because as you keep on moving for the nodes of the queue, then you will keep on adding the children of those nodes as well. So the queue size will keep on changing. So that is why you initially take out the size to understand that before I have started iterating the current level, what were the nodes, and I will store only those nodes inside my temp. And once that is done, then I will do what? I will, based on their level, I will either reverse my temporary list or I will not, and then I will change the level so that we can indicate that we have moved to the next level, and for that next level we will take the size again that we are doing here. So I hope that you have clearly understood this particular problem. I hope that you are clear. Thank you for watching this video, and please make sure to comment understood. Thank you.